Hello, everybody. My name is Francisco Naylor, and today I'll be teaching you about weather fronts. Why is this important information to know? Being able to understand the types of weather associated with the different types of weather fronts will allow pilots to determine in advance what actions will need to be taken and if the weather incoming will be suitable for flying. Different ways to view weather fronts are from reading a surface analysis chart, which can be found on aviationweather.gov, or by watching the news weather segments. They usually talk about fronts that'll affect the local weather. Some terms that are important to know: air masses. Air masses are large body of air that are the similar temperature and humidity throughout the air mass. They form when bodies of air take on the traits of the region it is over. Air masses can be created from various regions like polar regions, deserts, or oceans. The US is a bad location for air masses to be created because of the frequent winds disrupting the ability for air masses to take on the traits of the regions below them. Fronts. Most weather changes are caused along the perimeter of air masses, which are called fronts. One can identify if a front is moving in when there is a shift in temperatures, wind speeds, pressure, and an increase in cloud coverage or precipitation. Air masses can affect weather in regions for anywhere from days to months. Many Portland natives will know that weather here can change in a matter of hours. Some types of fronts. There are two types of air masses, cold and warm air masses, and these air masses can cause four types of fronts. The first type of front is called a cold front. In this front, a cold air mass is moving to a region to replace the warmer air mass. The second type of front is called a warm front. This does the exact opposite of a cold front, as it is a warm air mass that moves into a region to replace the colder air. The third type of front is called a stationary front, where a cold front and a warm front are right next to each other, and neither is replacing the other's place. The last front is called an occluded front. This is when a fast-moving cold front catches up to a warm front that is pushing away a colder air mass. Cold fronts, which are depicted by blue triangles on a surface analysis chart, are masses of cold, dense, stable, and drier air relative to warm fronts. They move at speeds of about 25 to 30 miles an hour. Cold fronts move in a way that shoves the warmer air mass out of the area. Since cold fronts are denser, they stay closer to the ground and force the warm air upwards. Types of weather that will form along a cold front depend on the stability of the warm air mass that is pushing away. This rapid, forceful raising of the warm air creates tall clouds, sometimes towering clouds like cumulonimbus. Prior and during the passage, cumulus clouds will often populate the sky. Only after the passage of the cold front do cumulus clouds begin to dissipate, and temperatures will remain cooler than before when the warm air mass was in the area. Warm air fronts, which are depicted as red semicircles on a surface analysis chart, are slow moving, typically only about 10 to 25 miles an hour. Warm air fronts have a slope that lays on top of the colder air mass to move it out of the area gently. Warm air fronts are very humid and, of course, warm. As the altitude increases, temperatures drop, and this causes various types of condensation, from nimbostratus to altostratus, and then cirrostratus and cirrus clouds. So yeah, when a warm front is moving in, stratiform clouds will likely be present, with cirriform clouds higher up, and there may be precipitation to accompany these clouds. After the passage of a warm front, the chances of precipitation increase and temperatures increase as well. Some more information about cold and warm fronts that should definitely be covered. There are cold fronts called fast-moving cold fronts that can reach speeds up to 60 miles per hour. If the warm air that's being overtaken is stable, overcast skies and rain may follow the passage of this cold front. If the warm air is unstable, thunderstorms and rain showers may appear after, during, or before the passage of the fast-moving cold front. Violent weather is usually associated with cold fronts, and the significant weather that occurs usually happens along the frontal boundary of the cold front. Although lines of thunderstorms can appear during the summer months as far as 200 miles in advance of the appearance of a strong cold front. Some comparisons between them, as stated by the PHAC, cold fronts are fast approaching with little or no warning, and they bring about a complete weather change in just a few hours. Whereas warm fronts provide advanced warning of their approach and can take days to pass through a region. Stationary fronts. They are depicted as a mix of red semicircles and blue triangles on a surface analysis chart. Stationary fronts are when a cold and warm front meet each other, but the force behind each of them are similar. It can be expected of stationary fronts to affect weather in the area for several days at a time. The weather that can be found in this area will be a mixture of that seen in both warm and cold fronts and will depend on which front is prevailing. Although weather will vary, it can be expected that clouds and precipitation will be in the area. Occluded fronts. They are depicted on surface analysis charts as purple semicircles and purple triangles. An occluded front is when a fast-moving cold front catches up with a warm front. And you can see all this information in the diagram below. On the left side, we have the fast-moving cold front, which is catching up to the warm front that's laying on top of this colder air mass. So yeah, as suggested by Gleim, it may benefit you to think of an occluded front as three different sections: a cold, fast-moving front, a warm front, and an area of cool air ahead of the warm front. There are two types of occlusions: a cold front occlusion, which is what's depicted below, and a warm front occlusion. Cold front occlusions lead to a mixture of warm and cold front weather, whereas a warm front occlusion can likely cause thunderstorms, rain, and fog. A cold front occlusion is when an approaching cold front is colder than the retreating cold air mass, and this phenomenon shoves the warm air mass upwards. The less common occlusion is when the warm front occlusion, where the less common occlusion is called a warm front occlusion, where the incoming cold front is less cool than that of the retreating cold front. In this scenario, the incoming cold front moves on top of the warm air, which will then cause thunderstorms and rain. And here are my sources. I referenced Gleim Aviation, which has a lot of books that will contain lots of useful aviation-related knowledge. I referenced the Aviation Weather FAA Advisory Circular, which is an FAA written book about aviation weather. And then the Pilot's Handbook of Aeronautical Knowledge, which I referenced earlier. It's called the PHAC, and it's an FAA written book about important aeronautical knowledge. And that concludes my presentation.